Dear grade 9, how are you today? Let's move on to our new lesson, which is operations on real numbers. So you know that this is about addition, subtraction, multiplication, and division of rational numbers and irrational numbers. First, let us look into the properties of real numbers. In smaller classes, you have come across these words. Commutative property. What does commutative property mean? It means that changing the order or the position, changing the order of numbers is called commutative property, which means, look at this equation. On the left side, A is the first number, and on the right side, A is the second number. We change the position. Still, the answer is the same. 2 plus 5 is 7. 5 plus 2 is also 7. The same thing will work with multiplication. 2 times 7 is 14. 7 times 2 is 14. So this is called commutative property. Now, associative property. Associative property means we are changing the groups. Groups means the numbers or integers or any type of numbers which are in the bracket. In the first bracket, we have A plus B. And on the right side, we have B plus C. We change the brackets, but still the answer remains the same. Look at this example, 2 plus 3 plus 5, which is 10. Again, 2 plus 3 plus 5 is also 10. Same work with multiplication also. But all of this, the main thing is you have to understand what's the meaning of associative or what's the meaning of commutative. Again, commutative means switching or changing the order. Associative means changing the group. Next is identity. Identity, for addition, we have the identity, which is 0, which means to any number, when you add 0, you will get the same answer. Whether it is at the end of the number or in the beginning of the number, you will get the same answer. So 0 is the identity for addition, and for multiplication, 1 is the identity. Because you look at this on the right side, A multiplied by 1 will give you A itself. Whether you multiply at the end or in the beginning, you will get the same answer. This is called identity. Now, inverse. Inverse means the opposite operation. For example, if you have a number 3, the opposite is minus 3. If you have the number 5, under multiplication, the opposite is 1 by 5. Let us see how they are. So if you have a real number A, its inverse is minus A. Have you thought of what if the number is minus 7? What is the inverse? Good, it is plus 7. So that when you take these two numbers together, you will get the answer 0. And even if you switch the order, it will be the same. Okay, now when you come to the multiplication, if you have the letter number A, its inverse is 1 by A. So if you have 3, the inverse is 1 by 3. So what is the inverse of 4 by 5? 4 by 5. The inverse is 5 by 4. Because when you multiply these two together, you will get the answer 1. Is that clear? Okay. Next one is closure property. Closure property means when you start with a type of number, for example, A is a real number, B is another real number, and your answer is also real number. This is called closure property. For addition, we add, and for multiplication, we multiply them. Let me give you a condition which is not under closure property. It will be more clear for you. For example, 3 is a natural number. 5 is also a natural number. When we minus them, we get the answer negative 2, which is an integer, not a rational number, right? Not a rational number. So we say that natural numbers are not closed under subtraction. So closed means when you start with a type of number, And when you do an operation, if you get the same type of number on the right side, which is called closed. So real numbers are closed under addition and also under multiplication. Now here we have the last one for now, distributive property. Distributive property means it's from the word itself. A letter A, bracket B plus C, can be written as, see, A multiply B is AB plus A multiply C is AC. So even if you have the number outside the bracket, it's the same situation. B multiply A is BA plus C multiply A is CA. These are all about a general introduction about properties of real numbers. Now let us see what are the rules when you add and subtract rational numbers and irrational numbers. Here I'm explaining for you some of the facts that you will come across when you add or subtract rational and irrational numbers. When we add or subtract a rational number with an irrational number, the answer will be irrational, which means if one of them is irrational, your answer is irrational. It is very simple here with this example. Look at this. Here, 3 root 5 is an irrational number. This is letter I. It is an irrational number. 4 is a rational number. Again, 7 root 5 is an irrational number. So when you add rationals and irrationals together, your final answer will be irrational number. Is that clear? Okay, now let's look into the second fact. When you multiply or divide a rational number with an irrational number, rational multiplied with irrational, what will happen to it? See, 5 is a rational number. 7 root 3 is an irrational number. Look at the answer. 7 times 5 is 35 and root 3 will stay with you. So 35 root 3 is irrational. So when you multiply rational with irrational, it is irrational. And here, now in the numerator, you have 12 root 10, which is an irrational number. And in the denominator, you have a rational number. Final answer is 12 divided by 6 is 2 with root 10. So 2 root 10 is irrational number. So what can we understand from here? When we mix rational and irrational, your answer will be irrational under multiplication. Also, when you divide rational with irrational number, your answer will be irrational under division. Okay. Now let's move on to the last fact from this section. Two irrational numbers. In the first two facts, we took rational and irrational. Now here we are taking two irrational numbers. When you add, subtract, multiply, or divide, the answer we can't predict. It can be rational or it can be irrational. Let's take two examples here. 3 root 11, this is an irrational number. 7 root 11 is also irrational number. You know that under the root, if you have same numbers, you can add them or subtract them. So 3 plus 7 is 10. So 10 root 11 is again an irrational. So two irrationals will give you irrational answer on addition. Now let's see another example with multiplication. 5 root 3 is an irrational number and 2 root 3 is another irrational number. When you multiply between these two, 5 times 2 is 10 and root 3 times root 3 is 3. You know that. Root 3, any root number multiplied by the same root will give you a whole number, which is 3 here. So 3, and you already have 5 times 2 is 10. 10 times 3 is 30. Is that okay? Okay. Now let's see how to represent or how to get the square root of a decimal number on a number line. In the previous lesson, you learned how to represent a whole number, square root of a whole number on a number line. Here we are representing square root of a decimal number on a number line. For that, we have to follow few steps. Step number 1, we have to draw a line of measurement 4.2. Remember, the question is square root of 4.2, but we take 4.2 centimeters. Okay. And then second step is from one end, add extra 1 unit. Add 1 unit extra or 1 centimeter extra. Look at this one. From the first point, let's mark this as O. And this is A. From O to A is 4.2. And from O, I extended 1 unit, either to the left or right, you can add, no problem. So let this be B. So altogether, from B to A, the unit will be B to A, it will be 4.2 plus 1, which is 5.2 centimeters. Okay. Now, the next step is take the middle of 5.2, midpoint. What is the midpoint of 5.2? Which will be 2.6 centimeters. It will be somewhere here. Keeping 2.6 as the center, draw a semicircle. That is the next step. Draw a semicircle. The semicircle is drawn for you. Here it is. And now, from the point O, extend or draw a perpendicular line. So that is your step number 5. Draw perpendicular line from O. Let us call this as P. So draw OP perpendicular to BA from O, perpendicular, 90 degree. So that number or the measurement that you get on OP will be the value of square root of 4.2. Simple. So I marked it by 6 steps, but it's easy. Quickly, first of all, we take the number without square root, 4.2 as the measurement. Add 1 unit. Then find the middle of it. Draw a semicircle. So far, this is just like a game or just like having fun. And then using your protractor, you can draw a perpendicular line 90 degree from the point O until you touch the semicircle. And then measure what is from O to P, you will get the answer. Either you can measure it using a ruler or you can just extend this point on a number line and see what measurement is it from O. This measurement will give you what is the value of square root of 4.2. Perfect? Excellent. Okay, now properties of square roots. Have you come across the properties of square roots ever before? Square root of A into B. AB means A into B. So when you have multiplication or division, you can separate the square root, which is square root of A, into square root of B. But remember, very, very important, we can't write as A plus B. This is wrong. Okay? Even if it is minus, you can't write it as minus B. They are wrong. But for addition, for multiplication and division, it is accepted, which means you can separate the whole root as separate roots, one for numerator and one for the denominator. Okay, now next let's come across the identity that you studied in grade 7 and 8, which is square root of A plus B, A minus B. What is A plus B into A minus B? Here it is explained. A plus B into A minus B is A square minus B square. You know that. And also, you need to know that when you have square root and square, they two get cancelled and it will be the letter alone. Keeping this in your mind, you have square root of A plus B, A minus B is A square minus B square. But here, A square means square root of A power 2. So it will get cancelled like this and it will be A alone. And in the identity, you will have a minus. Here is the minus. Then second one is square root of B power 2. Square root and power get cancelled and you will get B. So keep in your mind, if you have same numbers or same letters in the root, and if they are added in the first bracket and subtracted in the second bracket, your answer will be A minus B. We will get into it in details with the exercise. Now, A plus B whole square. Again, what is A plus B whole square? A square plus 2AB plus B square. Simple. So we have the same idea here, but square root of A square means it's only A plus 2 times square root of A times square root of B is 2AB plus square root of B power 2. that root and square will get cancelled and you will get this number. Is that okay? Now let's move on to one of the most important part of this lesson, which is rationalize the denominator. What is the meaning of rationalize? It's from the word itself, rationalize, rational. What's the meaning of rational? Rational number, right? So rational numbers, rationalize the denominator means that we convert the denominator into a rational number. You just have to look the denominator. Numerator is not a problem. So just look at this example. Is this denominator a rational number? No, you studied that root 2, root 3, root 5, root 6 are not rational numbers. So how can you change this into a rational number? It's very easy. What you have to do is multiply the numerator and denominator by the same number. Square root 5. So you multiply square root 5 in the denominator. And when you multiply it in the denominator, it should be multiplied in the numerator as well. Now what do we have in the denominator? Root 5 into root 5 is 5. So we have 5 in the denominator, and 1 times root 5 is root 5. So see the denominator now, which is 5, which is a rational number, right? We did. So we rationalize the denominator. So this is another example with 2 terms. Here we had only 1 term, but now you have 2 terms. When you have 2 terms, the situation is a little bit different. What you have to do is we have to take the conjugate. Conjugate means nothing. What you have to do is just write the same number 2. You have the number 2 plus square root 3. Just write the opposite of it. If you have plus, you write minus here. So that we will get the rule a plus b into a minus b. Okay, so 2 plus root 3 was the question. So you rewrite 2 minus root 3 in the denominator. Again, the same thing in the numerator as well. Okay, now let us simplify this one. In the numerator, you have 1 times 2 minus root 3, 2 minus root 3. And the denominator is a plus b into a minus b. What is a plus b into a minus b? A square. A square means 2 square, 4, minus b square. Square root 3 square is root 3 square. Root 3 and square get cancelled, so we get it is 3. Okay, so here we have 2 minus root 3 divided by 4 minus 3, which is 1. 2 minus root 3 divided by 1, we don't have to write it over 1. Now let's see another example. 5 minus root 2, 5 divided by root 3 minus root 2. In the denominator, you have 2 terms, so we have to open a bracket. See how to do that? This is called the conjugate. I thought of doing it in front of you so you will get a better idea. This is minus, so we have to take the opposite of minus, which is plus. And if you take the operation plus in the denominator, it should be the same in the numerator as well. So what we have now? In the numerator, we have distributive property. 5 root 3 plus 5 root 2 divided by a. Let us consider this is a and the other one is b. Okay, so this is, let us consider this is a and this is b. A minus b, again a plus b is a square minus b square. Square root of 3 power 2 is 3 minus square root of 2 power 2 is 2. So we have the answer 5 root 3 plus 5 root 2 divided by 3 minus 2. What is 3 minus 2? Which is 1. Is that okay? Let's move on to exercise 1.5. Classify as rational or irrational numbers. So try to remember the property that we learned. Look at this one. This is a rational number and this is an irrational number. A rational number added or subtracted with irrational number will give you a irrational number. So this is an irrational number. Okay, let's see the next one. This you can simplify actually. Look, plus 23, square root 23 and minus square root 23 will get cancelled. So your answer is only 3. So this is a rational number. Okay, let's see the next one. 2 root 7 by 7 root 7. When you have the same numbers in the numerator and denominator under multiplication, yes, they are multiplied. Under multiplication, they can be cancelled and you will get a fraction. Any number in the form of p by q, where p and q are integers, is also a rational number. Okay, next one, 1 by square root 2. Even if you rationalize the denominator, what number are you going to get? Square root 2 divided by 2. Here it is not in, it is in the form of p by q, but the numerator is not an integer, so this is not rational number, so it is an irrational number. Is that okay? Okay, now 2 pi. We already studied that pi is a non-repeating, non-recurring number, non-recurring, non-terminating number, which means it will not end, it will not repeat. So this is an irrational number multiplied by a rational number is also irrational number. Is that okay? Great. Now let's move on to question 2, simplify. And simplify, you know, you have to apply, this is A, B. Again, this is not A, so we have to apply distributive property. 3 times 2 is 6. Again, 3 times square root 2. Where did I get times from? Here. So 3 times square root 2 is 3 root 2. Remember, this sign is plus, also this is plus, so sign in between will be plus. Again, you have plus, again plus. 2 square root 3 is 2 root 3. Plus plus, it is plus again. Root 3 times root 2 is root 6. Now, all of them are different. Root 2 you can't add with root 3. Root 6 you can't add with root 6 with 6. So that's your final answer. And this is simplified. Okay, let's see the next question. See this one, they are the same. This is left, let's say this is A, this is B. Again, this is A, this is B. They are the same. A plus B, A minus B. So we can apply the rule A square, 3 square, minus B square, root 3 square. 3 square is 9, and root 3 and power 2 get cancelled. So it will be 9 minus 3, which is equal to 6. Perfect? Excellent. Now A plus B the whole square. What is A plus B the whole square? Which is A square. A square means root 5 square plus 2AB. 2AB is 2 root 5 times 2 plus B square is this one. Squares get cancelled. So we have the answer 5 plus 2 root 10, because 5 times 2 is 10, plus root and square get cancelled, so it is 2. And finally, you can take these two numbers together, because 5 and 2 are whole numbers. So it is 7 plus 2 root 10. Is it okay? Perfect. Now let's see the next question. Have you noticed that they are A and B? This is A minus B. Again, A plus B. A minus B, A plus B is A square minus B square, which is 5 minus 2, which is 3. Perfect, right? Let's move on. Question 3. Now, we have studied that pi can also be written in the form of C by D. This is actually from the rule that C is equal to pi D. Circumference of a circle is pi D. So when you keep pi as a subject, D will go down. So C by D. This contradicts the fact that pi is irrational. How to resolve this question? But what they are saying is this is an irrational number. But C by D means you have numerator and denominator, so it should be a rational number. How can you say that an irrational number is equal to a rational number? This we have noticed in lesson 2, that pi is either we substitute it as 3.14 or we replace it as 22 by 7. Both these cases are not 100% accurate. There is a minor error. We already discussed about it there. So this error will make the difference or will make the change from an irrational number to a rational number. So when you write pi is equal to c by d, which means that, of course, this is irrational number, there is no doubt about it. Now the only thing is either c will be an irrational number, or the diameter can also be an irrational number. Of course, the diameter can be a irrational number. Let's say root 3. Diameter of a circle is root 3. So one of them is irrational number. So when you divide, you will get an irrational number. But in our daily life, to do the calculations easier and better way, we consider pi is as a rational number, or c by d, all of them as rational number. Okay, move on to question 4. This is to represent a square root of a decimal number on a number line. So first of all, as we said, step 1, 2, 3, first step is we take 9.3 centimeters. Let's say this is from A to O is 9.3 centimeters. Step 2 is we add 1 unit. That is from O to A is 1 unit, or 1 centimeter, let us say. Step 3 is find the radius, or the middle of 9.3 plus 1, 10.3. So radius will be 9.3 divided by 2, which is equal to 5.15. So using a ruler, you can take, using a scale, you can mark where is 5.15. Somewhere here you will get the mark 5.15. Step 4 is you draw a semicircle. When you draw a semicircle, then draw, that's the next step. Step 5 is starting from O, draw a perpendicular line to touch the semicircle, let's say OP. So we draw OP perpendicular to AB. And the last step is represent OP on a, take OP on a number line. Here it is. So from here, O to P, this represents square root of 9.3. Remember, the first measurement we took is not root, it is just 9.3. But now when you take it is root of 9.3, and using a compass, keep O as the center and try to complete a circle or draw an arc. Then you can see that it is just touching just after 3, because you know that root 9 is 3. So root 9.3 means it is very close to 3, because the next number is root 16, 4. So root 16 is far away from this one. So this will be very close to 3 point, and you can see this is something like 3.04 something, because this is 3.14, which is the value of pi. So you can compare it from here actually. Hope that so far it is perfect. Now moving on to question 5. Rationalize the denominator. 1 by root 7. Now you are perfect with that, right? Let's see how to do that. Here. 1 by root 7, you can do it multiply by square root 7 on both the sides in the numerator and denominator. So you get the answer root 7 by 7, because root 7 is 7. Now look at this. This is a rational number. Next one. When you have two terms, you have to open a bracket and write the conjugate. Conjugate means the opposite. Square root 7 minus, so it will be plus. Square root 7 plus root 6. So we have square root 7 plus square root 6 multiplied by 1 will be the same, divided by a minus b, a plus b is a square minus b square. So which is equal to 7 minus 6. What is 7 minus 6? Which is 1. We don't have to write. This will be 7 and this will be 6. So 7 minus 6 is 1. Let's see the next question. Again, you have two terms. So you have to open a bracket and write the conjugate. Conjugate means the opposite. Square root of 5 minus square root of 2 in the numerator and denominator. Now, in the numerator, you have 1 multiplied by square root 5 square root 2 is root 5 minus root 2. And denominator is a plus b minus a minus b is root 5 square minus root 2 square, which will be these two get cancelled. Also this get cancelled. So we have root 5 minus root 2 divided by 5 minus 2. What is 5 minus 2? 3. That is your answer. Is that okay? Next question is 1 by root 7 minus 2. Again, we have to take the conjugate of this. So here, what's the conjugate of this question? 1 by root 7 minus 2. Root 7 plus 2 in the numerator and in the denominator. So we have root 7 plus 2 divided by a square minus b square is 7 minus 2 square. 2 square is 4. So what's your final answer? Root 7 plus 2 all divided by 3. Is it okay? Great. Let's move on to the end of the lesson, which is your homework session. So in your notebook, please try this one. We have done many simplification. So here we have to expand, or even you can apply the property a plus b, a minus b. This is a, we can consider this is a, this is b, a minus b, a plus b, and then you can apply a square minus b square. And the second homework is to rationalize the denominator. You multiply up and down by the opposite of square root 5 minus 2. Hope the lesson is perfect. Keep going. The math will be easy for you. So see you soon in the next period. Bye.